Hello, this is John Melendez, and this is a part B of the normal distribution. Confidence intervals. Let's look at this problem and see how we can solve this problem. A company manufactures parts. A random sample of 40 parts is taken and the length measured in centimeters. The sample has a mean length of 163.1 centimeters. Assume that the lengths are normally distributed with a population standard deviation of 44.6 centimeters. Your first step is to write down all your information. Your n is equal to 40, your x bar is 163.1, and your population standard deviation is 44.6. Write them down. That's going to be important. Now, they're going to ask you for the best point estimate. The best point estimate is always going to be your sample numbers. So your sample mean is your best point estimate. So that's going to be 163.1. It comes from here. Now, is it the same as your population mean? No, but it's going to be close to it. And I'm hoping that's going to be the case. That's what confidence intervals is all about. Think of a net that you're throwing out and seeing if you can catch the population mean. So now, how close? Well, that depends. That depends on how confident you want to be. The goal of the confidence interval on the mean is to find out how close your sample mean is to the true population mean. Okay, so I can say with a 95%, so here's what you have to say. When you're doing this problem on the test, you have to say, I can say with a 95% confident that the mean length of parts is between this number and this number, the lower limit and the upper limit. Okay, so now, and you have to choose your confidence level. Now, confidence levels are always two tails. Okay, you have a lower and an upper limit. Now, your alpha, which is your level of significance or your risk, how much you're willing to risk, that's not going to be there, it's going to be on the ends of the tails. So it's going to be half here and half there. So now, what we want to do is find these critical values. Okay, we call these the critical values. And how do we get them? Okay, so let's see how we get them. Now, first of all, let's say that we have the population mean here. Well, where's your x bar? Well, what if your x bar was right here? Okay, if your x bar was here on this side, if your x bar was here on this side, this is very low probability. So low that you would say it's highly unusual that this population mean is going to be true. So we want to know from what to what time, what to where, and it's going to be where it goes from unusual to could be, more likely to happen. Okay, so where would it be? Where? Let's see. Let's say if it was here. Yes, that would be more probable for it to be there because it's inside of 95%. So that's more likely. So where does it go from being more likely to not being likely? In other words, ordinary to unusual. And it's going to be right here on this right here. Now this right here, this distance is your margin of error. And this is going to be your upper confidence limit. Okay? So this is going to be your upper confidence limit. So that's going to be x bar plus e. Now, why would the population mean it's not going to be there? Well, because at a 0.025%, that's so low that most likely it's just not going to be there. Okay, so at a 0.025 probability, it's not going to be in there. So now let's look at the next part. On this side, we want to do the lower confidence limit. Now, if it was here, if the sample mean was there, that would be very unusual, okay, because that probability is so low. So we want to find out where would it go from being, well, let's look at this. What if this was right here? Well, that would be more likely. It would be more ordinary for it to be there. So where does it go from being more likely to being unlikely? Well, it's going to be right here at this limit right here. Okay, so this right here, this distance again is your E. and that's going to be your lower limit, your lower confidence limit. So basically, you're going to have your x bar minus your e. So, true or false, the sample mean is always the same as the population mean. False. So that's going to be false, but it's going to be close. Okay, the confidence interval contains the population mean values that would have the sample mean be 163.1 as ordinary or unusual. Well, we want it to be ordinary. Okay, so that means that the population mean is probably not going to be on this side, nor on the other side, nor on this one or this one. So we're going to look at in the middle. So now what we have here is this. These two are your limits. These are your confidence limits. So we're going to find out how to find those confidence limits. Here are the formulas for the confidence limits. First of all, this is only for where the population standard deviation is known. Okay? This is your margin of error. So let's look at this, our sample again, our example. This is the formula for the margin of error, and this is how you get the lower and the upper limits. So our first step is to find our margin of error. We have to find the critical value for 95%. So on our curve, we have 95% in the middle. That means that we have 5% on the ends. We split it in two and we get 0.025. Then we either use the calculator or the tables to find our z-score that corresponds with that. So that's going to be 1.96. You could also have gone it this way. You could have gone to your calculator, okay, and turn it on, and gone to second inverse, gone to inverse norm, and gone ahead and put in 0.975. Okay, and press enter and you get 1.96. Okay, so here's the thing. Okay, so now 1.96, and that's how you get your z-score. Okay, so now that you have your z-score, you're going to use this formula in order to find your margin of error. So you have 1.96 times 1.96 times your standard deviation, which is 44.6, divided by the square root of 40. Remember, this is your standard error. Now that you have that, that's your E as 13.82. To find your limits, you're going to add it and subtract it from your sample mean. So to find the lower limit, you subtract 13.82 from 163. And to find your upper limit, you take 163.1 plus 13.82. Therefore, you get your lower and upper limits. So now we can say with a 95% confident that the mean length of parts is between 149.3 and 176.9. And that's how we do it. That's our graphical display. So that's what we have it. So let's look again. Number 1, get your information and write it down. Number 2, find your z-score. Inverse norm or tables. Number 3, put it into the formula. Find your margin of error. Number 4, subtract it from your sample mean to find your lower limit. Add it to your sample mean to find your upper limit, and you get your answer. You can say with a 95% confident that the mean length of parts is between 149.3 and 176.9 centimeters. Okay, the other way to doing this is by using the calculator. So if you use the calculator right here, what you're going to do is this. You're going to go to stat, you're going to go out to test, and you're going to go out to z-interval. Now why z-interval? Because you have a population standard of deviation. Okay, so now you're going to put in your numbers. Your population standard deviation is 44.6. Okay, your sample mean is 163.1. Your sample size is 40 and your sea level is 0.95. And then you hit the calculate button and you get the same answer, 149.3 to 176.9. And that's going to be your answer. Now, I don't think I have StatCrunch going in right now. Okay, so let me go ahead and get into StatCrunch. And so let me go ahead and go to StatCrunch real quickly. Okay, sorry. Let me go to StatCrunch. I need to go by Google because it's easier to do it through Google Chrome. And I'm going to go ahead and put in my Pearson account. And hopefully it'll come up soon through StatCrunch. Okay. It's taking it a while. I apologize for that. But we do want to know how to do it through StatCrunch. Okay, so now that we have that open, our next step is going to be to go ahead and go to StatCrunch. So we're going to go over here to StatCrunch. Okay, now where we're going to go for the confidence intervals is going to be the same kind of place that you went for calculators. So we're going to go to Stats, but instead of going to calculators, you're going to go out to the Z-Stats. You're going to go to one sample and you're going to go with summary. The difference is with summary is when you have the numbers already given to you. The sample mean, the standard deviation, the sample size, and everything else. With data is if you just had a set of numbers. Then you would just put in the data or at least set it as a variable and then StatCrunch would go from that variable. So we're going to go with summary right here. Okay, so now the sample mean, we're going to go back over here. Go back over here and look at our information. So our information is basically going to be that our mean is going to be 163, okay, 0.1. Our standard deviation is 44.6 and our sample size is 40. Okay, so now that we're going to go over here back to our StatCrunch. Okay, we're going to go over here to our StatCrunch and we're going to enter our numbers. So our sample mean is 163.1. Okay, our standard deviation is going to be 44.6. Our sample size is going to be 40. Okay, now we want to find confidence intervals, and our confidence level is going to be, in this case, 95%. So we want a 95% confidence level. Okay, so now we're going to have, let's go back to StatCrunch, and we're going to put in 0.95, it's already in there. Now we're going to hit the compute. When I hit compute, I get my confidence interval right here. Okay, so it's going to be from 149.3 to 176.9, which is basically what we have in the answer right here. So you can use StatCrunch, the calculator, or through the formulas. Okay, thank you very much. Oh, before we do this one, before we finish, let's try this one. Try this one. Assume it's normal distribution. But go ahead and try that one.